Introduction. Projectile motion is a motion associated with gravity. It can be compared to free fall except that projectile motion is a two-dimensional motion. It consists of a vertical motion with a constant acceleration of g or gravity and a horizontal motion with a constant velocity. Thus, this video laboratory report aims to prove that a dropped ball and a ball shot horizontally will reach the ground at the same time, given that they were released simultaneously and at the same height. Theory. Certain equations are used in projectile motions. One technique is to represent the given data in vector forms. Through this, vectors for r of t, v of t, and a of t are obtained. Methodology. Search video on YouTube. Track the motion of the balls using tracker. Plot the data in Excel. Analyze the graphs. The video they searched had a setup like this. The device used consists of a spring-loaded rod that shoots the ball horizontally. The second ball, which has a hole in it, was slipped through the other end of the rod so that when the spring is released, ball 1 is shot horizontally and ball 2 slips off the rod to fall towards the ground. The device is clamped onto a pole-like structure that holds it in place at a certain height. The table served as a basis of measurement. The video was set up in 60 FPS, which means that the video is in slow-mo. Results and discussion. Ball drop had a graph like this. The blue line corresponds to the horizontal displacement, the orange line corresponds to the vertical displacement, and the gray line corresponds to the velocity at y. As observed, the horizontal displacement is very close to zero. This may be because the ball was just dropped. This means that the ball had no or very little initial horizontal velocity. Also, the only force acting on it is gravity, and because of gravity, its vertical motion was to go down and be pulled by it. Ball 1 reached the ground at approximately 1.03 seconds. The blue line corresponds to the horizontal displacement, the orange line corresponds to the vertical displacement, and the gray line corresponds to the velocity at y. The graph shows that ball 2 moved 1.21 meters towards the right, which corresponds to the positive slope on the graph of x of t. This also means that ball 2 had a positive initial horizontal velocity. The graph shows a negative slope, which means that ball 2 was also affected by the force of gravity as it fell towards the floor. Ball 2 also reached the ground at approximately 1.03 seconds. Conclusion. Through this, it can be concluded that both balls reached the ground at about the same time. Also, since ball 1 had no horizontal velocity, it can be compared to free fall. And since ball 2 had both a horizontal velocity and a vertical velocity, it can be compared to a projectile motion. Finally, using the graphs and data obtained, it is to say that both the horizontal and vertical components in the projectile motion are independent with each other, as the horizontal component in ball number 2 did not affect its vertical component, which then rendered the same final time with ball number 1, which had no horizontal component.
Show, baby, how you rock it.